All right, so what I have here is a simulation of a neuron. So we have our cell membrane here, which is what the paper clips are, and we have the outside of the cell over here and the inside over here. So what we have also is we have a neurotransmitter, which is a little red dot here, and we've got sodium, which is all the white, and potassium, which is all the blue. So in a resting state, we're going to have more sodium on the outside of a neuron and more potassium intracellularly of the neuron, so inside the neuron. On the cell membrane, we have basically two different types of channels. We have a chemically gated channel, which is what these orange paper clips are here. They are going to open in response to a chemical. So when a chemical binds to it, it's going to open the channel. The other ones, which are pink and purple, are both voltage gated. The pink ones specifically are to allow sodium in, and the purple ones are to allow potassium out. So they're voltage gated, which means they're going to open in response to a change in voltage. So let's say that we are receiving a signal. So that signal is going to send a neurotransmitter. The neurotransmitter is going to bind to the chemically gated channel, and it's going to open that channel. As that channel opens, it's going to allow for sodium to rush in. As sodium rushes in, we now have a concentration gradient on the inside of the cell. So it's now going to diffuse. As it diffuses, it's going to hit a voltage-gated channel. Well, we've changed the voltage in this area by adding that positive charge from the sodium. So that's going to cause the sodium voltage-gated channel to open, and more sodium is going to rush in. Once that sodium rushes in, we now have a concentration gradient. So once again, it's going to diffuse. As it diffuses, it's going to hit another voltage-gated sodium channel. So that sodium channel is going to open, and it's going to allow sodium to rush in. So that's the act of depolarization. In repolarization, our sodium channels are all going to close. And now we have to get back to a negative interior. And the way we do that is we open our potassium channels, which are voltage gated. So that's going to open. As that opens, our potassium is going to rush out. As it rushes out, it changed the membrane potential here. So it's going to open another potassium channel. That's also going to cause it to rush out. Same thing. It changed the voltage, so it's going to cause that third one to open and allow our potassium to rush out. We then also have some extra potassium that rushes out in that hyperpolarization, so we end up with just it being a little more negative on the inside than we started with. So you'll notice that now we have essentially gone back to our resting state where we have more positive charges on the outside and more negative charges on the inside. The problem that we are going to encounter now is that the ions are on the wrong side. So the majority of our sodium are actually inside the cell, and the majority of our potassium is actually on the outside. So now we have to go through the process of restoring those ionic conditions. We need to get the potassium in, and we need to get the sodium out. And how do we do that? We use the sodium potassium pump. So I don't have paper clips that show that, but I'm going to use my hands because it is a active process, which means that we're going to have to use energy to do that. So what we're going to do is we're going to take 3 sodium ions from inside the cell, push them out, and when we push out those 3 sodium, we're going to plug in 2 potassium. As we move down, same thing. 3 sodium are going to be pushed out, 2 potassium are going to be pushed in. Down here, 3 sodium back out, 2 potassium back in. So once again, we still have that positive exterior, we still have the negative interior, but now our sodium is relatively on the right side and our potassium is back on the inside, which is a good thing. We've got a couple extra here. Those will eventually move back. I just don't have enough to actually show that entire process, but we're kind of back to that resting where we're going to have positive charges on the outside, which are sodium, potassium, which are positive charges, but there's less of them, so they're going to have that negative charge on the inside of the cell.